So if secant x plus tan x is equal to p, then show that sin x is equal to p square minus 1 by p square plus 1. Let us solve this question. So we know that secant square x minus tan square x equals to 1. You have this one as secant x plus tan x multiplied by, you can break this like a plus b into a minus b, so it becomes secant x minus tan x tan x, that becomes 1. So these two are reciprocal to each other. So what I mean to say is that you have secant x plus tan x. If it is equal to p, then you can say that secant x minus tan x will become 1 by p. Then only this product goes to 1, right? This, if this part is p, this is like 1 by p, because the reciprocals will multiply to become 1. Okay, so that is the basic idea. Now what we do is just add up these two equations. So the tan x gets cancelled out, so you get 2 secant x, that becomes p plus 1 by p. And similarly, you take the same equations once again, secant x minus secant x plus tan x, that is equal to p, and you have secant x minus tan x, that becomes 1 by p. Now you just take a subtraction of these two equations. So when I subtract, we'll change the signs and then add up. So the secant x gets cancelled out, so you get 2 tan x. 2 tan x becomes p minus 1 by p. So like this you get. And now what we can do, so I want to find the sin x from this. So it is pretty simple. So from this we have what I can do is, using this I can find the value of secant x. Secant x has become p square plus 1 divided by 2p, that is secant x. And similarly I can get the value of tan x as p square minus 1 divided by 2p. So from this I can make out what is the value of cos x. Cos x is reciprocal of secant x, so that is 2p by p square plus 1. So this is what I'll get. Now I need to find the value of sin x. Okay, sin x I want to find. To get sin x, it is pretty simple. Sin x is the product of tan x and cos x. So tan x multiplied by cos x will give us sin x, because I know very well that tan x is sin x by cos x. So let us plug in the things. So I get the value of sin x as sin x is tan x. Tan x value is p square minus 1 divided by 2p, and the cos x value is 2p by p square plus 1. So you have the 2p gets cancelled out, and then the sin x is you get p square minus 1 divided by p square plus 1. So that's the answer. That's the required answer. Hope you like it. So this is the next question. If m is equal to tan x plus sin x and n is equal to tan x minus sin x, then show that m square minus n square is 4 root mn. So this is what we have to prove. So for that we will use the identity tan square x minus sin square x is equal to tan square x multiplied by sin square x. Tan square x multiplied by sin square x. So this is a very important identity in trigonometry. So here we have to know something, that tan square x is sin square x by cos square x. This is, all of you know this, sin square x by cos square x. All of you know this. And now, so I can write wherever I can write cos square x. Cos square x happens to be sine square x divided by tan square x. Like this you can write. So this is one of the important thing we'll use to solve this particular identity. So this identity all of you have to know. So what I will do is I'll take the LHS first. Let us prove this identity. This identity we need to know. So LHS will take and then take tan square x as common. Tan square x is common. Tan square x as common. Then 1 minus I'll get sine square x by tan square x. Like this we can take the tan square x as common. Okay. So when I have sine square x by tan square x, I can replace this with cos square x. So you have tan square x multiplied by 1 minus cos square x. Like this you can replace. We just seen this transformation just now. Now I can, wherever I see sine square x by tan square x, I can replace with cos square x. So you have this replacement. So I know another thing. 1 minus cos square x is nothing but sine square x, hence the relation. So 1 minus cos square x you can always replace with sine square x. So you got the RHS. So this is the relation we have to know. So tan square x into sine square x on the right hand side. So this left hand side we have tan square x minus sine square x. So wherever I see tan square x minus sine square x, I can replace that with tan square x into sine square x. Or when I see tan square x minus tan square x into sine square x, I can replace with tan square x minus sine square x. So this is the important thing to solve this particular question. Now let us see what happens right now. So I had to find, let us go to the original problem. I had to write m square minus n square. So what is m square minus n square? M is tan x plus sin x. So for that you got to take a whole square. Okay. And now minus, you have tan x minus sin x, and then you have a whole square for it. You have whole square for it. So okay, you have something here. So you have a plus b whole square minus of a minus b whole square type of situation. This is nothing but 4ab. So this you can replace with 4ab. So where a is nothing but tan x, then b is sin x. So you can replace this with 4 tan x multiplied by sin x. And now let's write this as a little bit in a complicated form. So it's not that complicated, just we will take this into square root. So we'll write like tan square x multiplied by sin square x, like this we'll write. Okay. And now wherever I see this product tan square x into sin square x, I can make it like a difference. Okay, just now we have seen that relationship. So that relation we are going to use now to solve this problem. So this becomes 4 times. I can use that relationship. I can very well write this as tan square x minus sin square x. Okay. So you have this. And now this is like a square minus b square. So let's write that in the form of a plus b into a minus b. So let's break that into tan x plus sin x multiplied by tan x minus sin x. We just break that. Okay, tan x minus sin x. We just break this off. So, but tan x plus sin x in the problem they have given it as that is square root of this part. The first part of the problem is nothing but m, and second part of the problem is nothing but n. That's the answer. So that's the answer. So you have the situation. So that is our required. That is our required RHS. Okay, you can see that. So we finally got 4 root mn. Okay, so we hence proved m square minus n square is 4 root mn. So that's the problem and hence proved. So QED. So with that, that's the problem. Okay, let's see another problem. So let's see the problem number 3. It is given that m is equal to a cos x plus b sin x and n is equal to a sin x minus b cos x. Then you got to show that m square plus n square is equal to a square plus b square. This is a relatively very easy problem. You just have to square it and add up the things. That's easy. Actually, this is relatively easy compared to the other problems what we have solved just now. So what is given is m is equal to a cos x plus b sin x, and n is given as a sin x minus b cos x. This is what is provided to us. Now what we have to do is m square plus n square is what we have to do. So the m square part is always take the bracket and then take the whole square. Okay, a cos x plus b sin x. Some two things are adding up, you got to take the bracket and then square. Okay, so that you had to follow. So don't, some students they will something like they will individually square the things. Okay, that is not correct. You got to open up the brackets and then square. So that you have to remember. Okay, so don't commit that kind of silly mistakes. Okay, now so let's square this. This is a plus b whole square like this. So that is a square cos square x. So both the things take the square, and the b square part is b square sin square x. Both the things which are in multiplication they will take the square, plus 2ab. 2ab part is 2ab sin x cos x. Okay, cos x sin x in this case, or sin x cos x, that is all okay. So cos x sin x. And now let us take this term, and this is like a minus b whole square. So this is a square sin square x plus b square cos square x and minus 2ab sin x cos x. Okay, sin x cos x. Now let us see what happens. 2ab sin x cos x and 2ab cos x sin x, these two gets cancelled out. Okay, now what we have is, so what we are left with is a square cos square x is there and a square sin square x. We can take a square as common out of these two terms. A square is common. You have cos square x plus sin square x. Okay, cos square x plus sin square x here, and plus you have b square can be taken as common out of this term and this term. So b square into, you have again sin square x plus cos square x, and you have sin square x plus cos square x is 1. We know this very well. Sin square x plus cos square x will be 1. So hence the result a square plus b square. So which is our required RHS, and you have m square plus n square is equal to a square plus b square. This is hence proved, QED, hence proved. Okay, so that's the required result. So let's move on to the next problem. Yeah, let's see the next problem, question number 4. That is a cos x minus b sin x. A cos x minus b sin x. A cos x minus b sin x is equal to c. Then you got to show that a sin x plus b cos x is plus or minus square root of a square plus b square minus c square. It is important that uh, you remember this as a result. That is one of the important questions for even for JEE at the level, and it's important for Olympiad exams also. Some of the questions, and it's important for the university level examinations also, something like an MSET sort of examination. Uh, and let us see the thing. You were given that a cos x minus b sin x is equal to c. And now this problem can be solved by just squaring on both sides, and then you have to apply the relation. You got to know the relation sin square x plus cos square x happens to be 1. So when you use this relation and then you just square it on either side, and then you are done with this problem. So just I am taking the squares on either side, so directly writing that. And now when you square it on either side, you get, this is like a square, a minus b whole square. So a square cos square x, so plus b square sin square x you have, and minus 2ab cos x sin x is what you have. Sin x is what you have, and that happens to be like c square. So let's see what we can do. So here what we'll do is we'll just replace this cos square x as 1 minus sin square x and sin square x as 1 minus cos square x. This is what we are going to do. When you are replacing, you will open the bracket. Whenever you are substituting, it's a good habit to open the bracket. Then only you will get the right answers. Okay. So it is b square. I am substituting 1 minus cos square x in the place of sin square x. So you have to open the brackets. That's important. And then 2ab cos x sin x, we'll leave it as it is, minus 2ab cos x sin x. We are leaving it as it is. And this thing is equal to c square for you. And now let's see what happens. Let us see what happens. And here you have let's multiply this. A square into 1 is a square minus a square sin square x is what you have. And you have plus b square minus b square cos square x. Just multiply the b square into the bracket, and similarly I did a square into the bracket. I just multiplied here. And now minus 2ab cos x sin x is what you have. And then again this side you have c square. Okay. And now what I will simply do is, on the left side I have the negative terms. Take all the negative terms onto the side, and so I had to do the next step. Its problem is over actually. This negative terms, whatever negative terms are there, you just send to the other side, and we will swing the c square towards this side. We'll swing all the negative terms to the other side. So when I do that, I have this situation: a square plus b square minus e square. I am swinging the c square to this side and taking all the negative terms onto the other side. So wherever the negative terms, these three are the negative terms, those three I am taking to the other side. So I have a square sin square x plus b square cos square x plus b square cos square x, b square cos square x plus let's write this as 2a sin x multiplied by b cos x. If I write like this, you will see the a plus b whole square type of formula. That's the reason I am writing this term like this. Okay. So let's observe this. So you have a square plus b square minus e square over here, and this side let's observe. This is like a square, this is like b square plus 2ab. Okay, a square plus b square plus 2ab. What is that? A plus b whole square. So you have a sin x plus b cos x whole square. So instead of a you have a sin x, and instead of b you have b cos x. And 2ab, instead of 2ab, you have 2a sin x and b cos x. So here, so let's rewrite this, the LHS and RHS. Just rewrite this thing on left and right. I can write like this. So a sin x plus b cos x. Yeah, I have this thing as a square. The problem is over. Okay, you have a square plus b square minus e square. If I remove the square, I had to put the square root on this side, right? So if I remove the square, a sin x plus b cos x, obviously the other side square root of this thing will come, square root of a square plus b square minus e square. But always remember, the square root of some quantity is always a positive number. So so the answer for a sin x plus b cos x can be a positive number as well as negative number. So we'll put the plus or minus sign. But always remember, square root of x square is actually mod x. You got to know this. This is very important, very important. So it's very important, fundamental. So always square root of a number is going to give me a positive quantity. Always a positive quantity it gives. The square root of a number will not give me a negative quantity. So but a sin x plus b cos x can be also a negative quantity. So the reason plus or minus, and the square root of this number is a positive quantity. So plus or minus, it can give a positive or negative number. So that is the thing which you have to know. So this is the concepts. Okay, let's go ahead to the next one. Let's go to the next one. So let's see the fifth question. The question is like this. It is given that cos x plus sin x is root 2 cos x, then you got to show that cos x plus sin x is root 2 cos x, and you got to show that cos x minus sin x is root 2 sin x. It is pretty simple. What we have to do is cos x plus sin x. We write like this, and then you have root 2 cos x. Let's write up the equation. And what I will do is just swing the cos x onto the other side. So I can write sin x is equal to you have root 2 cos x minus cos x. You can write like this. And later what I'll do is I'll take the cos x as common, and again you have sin x is equal to you have root 2 minus 1 multiplied by cos x. If I take cos x from the both the terms, this is what I'll get. And afterwards it's pretty simple. And then we have cos x, we'll write it as this root 2 minus 1 thing, just swing it on the other side. So when you swing it, it becomes this side it's multiplying, so that side it will go to the division. That means it will go to the denominator. So 1 by root 2 minus 1, it multiplies with sin x. Then what I will do is I will rationalize the denominator. So rationalization means just multiply with root 2 plus 1 divided by root 2 plus 1. So I think it's not clear. I will rewrite here. Here I'll rewrite. So I'll rewrite that step here. So you have cos x is equal to sin x divided by root 2 minus 1 is there. So let's multiply and divide with the root 2 plus 1, and we multiply and divide with root 2 plus 1. And now this on the numerator you have root 2 plus 1. So multiplied by sin x. So let's observe the denominator part. This is like a minus b into a plus b. So it is root 2 whole square minus 1 square, right? So this is nothing but 2 minus 1, which is 1. I am not writing that. So it is denominator anyway, it's 1. So you have root 2 plus 1. You have sin x here. Now what we do is almost the problem is over anyway. So what you have is you have cos x. Cos x is equal to root 2, just multiply root 2 sin x is what you have, and plus sin x is what you have, and just swing the plus sin x towards the side. So you have the result cos x minus sin x is equal to root 2 sin x. So that's the required result. So QED hence proved. So that's it. So let's see the next problem.